Hi friends, here I am with the second video of trigonometry. Before moving on to the part 2, let me rewind the previous topic, that is trigonometric ratio. The 6 trigonometric ratio are sine theta, and this is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is opposite side by adjacent side. And the rest 3, that is cosec, sec and cot, are the reciprocals. That is, cosec theta is hypotenuse by opposite side, sec theta is hypotenuse by adjacent side, and cot theta is adjacent side by opposite side. Now, let us see trigonometric ratios of some specific angles. In this section, we shall find the trigonometric ratios of some standard angles by using some elementary knowledge of geometry. The standard angles are 0 degree, 30 degree, 45 degree, then 60 degree and 90 degree. Before that, let us consider our figure, that is the line segment AX and AY, and the angle between them is theta, and P be a point on AY and a perpendicular drawn to AX. Let this point be M. Now, first let us find the trigonometric ratio of 0 degree and 90 degree. For that, let us consider angle XAY. This is acute angle theta. And we know sine theta is equal to Pm by AP, that is with reference to theta opposite side by hypotenuse, Pm by AP, and cos theta is equal to Am by AP, that is with reference to theta adjacent side Am by hypotenuse AP. Similarly, tan theta is opposite side by adjacent side, that here it is come out as Pm by Am. And it is evident from triangle AMP that as theta becomes smaller, the line segment PM also becomes smaller. And finally, when theta becomes 0 degree, the point P will coincide with M. That is, let me say, when theta becomes 0. When theta becomes 0, first condition. Theta becomes 0, the line segment PM will be equal to 0. This is because the point P will coincide with M. P will coincide with M. And as a result, PM is equal to 0. And when PM is equal to 0, AM and AP remain the same. AM will be equal to AP. Now we have got two conditions, that is PM equal to 0 and AM equal to AP when theta is equal to 0 degree. Now let us find the sine, cos and tan. Sine 0 is equal to PM by AP, that is with reference to theta or 0 degree, here theta is 0 degree, opposite side by hypotenuse, that is PM by AP. You know PM is equal to 0 and by AP we get 0. Now cos 0 degree is equal to adjacent side, here adjacent side is AM by hypotenuse. This is equal to, we know AP equal to AM when theta is equal to 0 degree. Therefore numerator and denominator remain same. Therefore cos 0 is 1. Now tan 0 degree is equal to opposite side by adjacent side. We know PM is equal to 0 by AM is equal to 0. Now next 3, that is cosec, sec and cot are the reciprocal of sine, cos and tan. Cosec 0 is equal to AP by 0, that is 1 by sine. This is equal to not defined, because when the denominator is equal to 0, the value obtained is not defined. Now next, sec 0 is equal to 1 by cos. Here 1 by cos is 1 by 1 is equal to 1. Now last one, cos 0 is equal to am by 0, that is 1 by tan. Tan is 0 and reciprocal is am by 0 is equal to not defined. Now considering the same triangle, we can see that when the value of theta increases, the line segment AM becomes smaller, and finally when theta becomes 90 degree, the point M will coincide with A. The point M will coincide with A. Consequently, the value of AM comes out as 0 and AP will be equal to AM. The two conditions are obtained, that is AM equal to 0 and AP equal to AM when theta is equal to 90 degree. Now let us see, sine 90 is equal to PM by AP. Here PM and AP are equal, therefore numerator and denominator being equal, the value will be 1. Now cos 90 is equal to AM by AP. We have an observation that AM is equal to 0, therefore this comes out 0 by AP, which is equal to 0. Now tan 90 degree is equal to PM by AM. This is equal to, we have PM is equal to PM by AM equal to, we know AM is 0, therefore PM by 0 is equal to not defined. Now cosec, sec and cot, the reciprocals. Cosec 90 is the reciprocal of 1 by sine 90. This is 1. Now sec 90 is reciprocal of cos 90. This is equal to 1 by 0 is not defined. Now cot 90 is the reciprocal of tan, 1 by tan. Here we have 1 by not defined. So let me clear that. 1 by not defined, that is 1 by PM by 0. This is equal to 0 by PM. This implies 0. This is a table showing the trigonometric ratios of 0 and 90 degree. Let me say, sine 0 is 0, sine 90 is 1, cos 0 is 1 and cos 90 is 0. Tan 0, 0, tan 90 is not defined. Then cosec 0 is not defined and cosec 90 is 1. Sec 0 is 1 and sec 90 is not defined. And the last one, cot 0 is not defined and the cot 90 is 0. Now let us find the trigonometric ratio of 30 degree and 60 degree. For that, let us consider an equilateral triangle. Consider an equilateral triangle A, B, C, and let each side of the length be 2A. And being an equilateral triangle, the each angle will be 60 degree. Let me write. Consider equilateral triangle ABC, length of each side be 2A, and being an equilateral triangle, each angle will be equal to 60 degree. Now let AD be a perpendicular BD be a perpendicular from B on AC. BD be an perpendicular on AC. Since the triangle is an equilateral triangle, BD is the bisector of angle B. That is, BD is a bisector of angle B. Therefore, angle ABD will be equal to 30 degree and angle CBD will be also equal to 30 degree. This is because being an equilateral triangle, BD is the bisector of angle B. And D is a midpoint of AC. D is midpoint of AC. Therefore, D being the midpoint of AC, AD is A. Now, length of AD is A. Consider right angle triangle ABD. With Pythagoras theorem, we know AB square is equal to BD square plus AD square. That is, hypotenuse square is equal to perpendicular square plus base square. Now, BD square is equal to AB square minus AD square. We know AB square is 2A whole square minus and AD square is A square. This implies 4A square minus A square, which is equal to 3A square. Thus, we can obtain the value of BD. BD comes out as root 3A. Therefore, BD is root 3A. Now, let us find the trigonometric ratio of 30 degree. For that, consider triangle ABD. Let the reference angle be angle ABD, which is equal to 30 degree. So, with reference to 30 degree, the base is BD and this is equal to root 3A. And here the base means adjacent side. Then the perpendicular is AD, which is equal to A. Perpendicular is opposite side. And the hypotenuse is 2A. We got BD is equal to root 3A. Then AD is equal to A. And then AB is equal to 2A. Now, considering 30 degree as a reference angle, let us find the trigonometric ratio. Sine 30 is opposite side AD by hypotenuse AB. We have AD is equal to A and hypotenuse AB is equal to 2A. This implies sine 30 is equal to 1 by 2. Similarly, cos 30 is equal to adjacent side with reference to the angle. The adjacent side with reference to the angle is BD and the hypotenuse is AB. This is equal to root 3A by 2A, which is equal to root 3 by 2. Now, tan 30 is opposite side, here opposite side is AD and adjacent side is BD. This is equal to A by root 3A. This is equal to 1 by root 3. Now the rest 3 are the reciprocal. It's easy to find. Cosec 30 is reciprocal of sine 30. Reciprocal of sine 30 is 1 by 2. This is equal to 2. Now sec 30 is a reciprocal of cos 30. It is 1 by root 3 by 2. Is equal to 2 by root 3. Then cot 30 is a reciprocal of tan. It's 1 by root 3. Is equal to root 3. Let me say sine 30 is 1 by 2, cos 30 is root 3 by 2, tan 30 is 1 by root 3, cosec 30 is 2, sec 30 is 2 by root 3 and cot 30 is root 3. Now let us move on to the trigonometric ratios of 60 degree. Trigonometric ratios of 60 degree. Here the reference angle is 60 degree. Therefore, the opposite side with reference to the angle is BD, which is equal to root 3A. We write root 3A, A to A. And the adjacent side with respect to the angle is AD, which is equal to A. And hypotenuse remain the same, that is AB is equal to 2A. Now, that is fine. Sine 60 is opposite side by hypotenuse. Opposite side is BD and hypotenuse is AB. We have BD is root 3A by 2A is equal to root 3 by 2. Now cos 60 is adjacent side by hypotenuse. This is equal to adjacent side is A and hypotenuse is 2A, 1 by 2. Now tan 60 is opposite side by adjacent side. Here opposite side is BD and adjacent side is AD. This is equal to root 3A by A implies root 3. Now the rest 3, that is cosec 60 is equal to 1 by root 3 by 2, that is reciprocal of sine 60 is equal to 2 by root 3. Now sec 60 is 1 by 2, that is reciprocal of cos 60. This comes out as 2. Now cot 60 is 1 by root 3 is equal to 1 by root 3. Let me say sine 60 is root 3 by 2, cos 60 is 1 by 2, tan 60 is root 3, cosec 60 is 2 by root 3, sec 60 is 2 and cot 60 is 1 by root 3. This is a table showing the trigonometric ratios of 30 degree and 60 degree. Sine 30 1 by 2, cos 30 root 3 by 2, tan 30 1 by root 3, cosec 32, sec 30 2 by root 3, cot 30 root 3. Now sine 60 root 3 by 2, cos 60 1 by 2, tan 60 root 3, cosec 60 2 by root 3, sec 60 2 and cot 60 1 by root 3. Now trigonometric ratios of 45 degree. For that, let us consider a right angle triangle ABC. Let's consider a right angle triangle ABC. This is 90 degree, this is 45 degree, this is 45 degree. And being this two base angles to be 45 degree, AB will be equal to BC. That is, it become an isosceles triangle. So, let AB equal to BC equal to A. By Pythagoras theorem, we have AC square is equal to AB square plus BC square. AB is A and BC is also A, therefore A square plus A square, 2A square. Therefore AC is equal to root 2A. Therefore AB is A, BC is A and AC is root 2A. Considering any one angle, let us consider angle A. Let angle A be the reference angle. With the reference angle, AB is the adjacent side, that is the base, is equal to A, and BC is the opposite side, that is the perpendicular side, that is equal to A, and AC is the hypotenuse, this is equal to root 2A. Now sine 45 is opposite side of this angle to the hypotenuse. Here opposite side is BC and hypotenuse is AC, and opposite A by root 2A is equal to 1 by root 2. Similarly, cos 45 degree is equal to adjacent side to that of the angle to hypotenuse AC. So also A by root 2A equal to 1 by root 2. Now tan 45 is equal to BC by AB, that is opposite side by adjacent side. From the figure it is clear that both the sides are equal, therefore tan 45 is equal to 1. Now cosec 45 is a reciprocal of sine 45, therefore 1 by root 2. This is equal to root 2. Then sec 45 is the reciprocal of cos, 1 by root 2. This is also equal to root 2. Now cot 45 degree is equal to 1 by 1 is equal to 1. Let me summarize. For 45 degree, sine, cos, tan, cosec, sec and cot. Sine 45 is 1 by root 2, cos 45 is 1 by root 2, tan 45 is 1, cosec 45 is root 2, sec 45 is root 2 and cot 45 is 1. Now we will see trigonometric ratios of complementary angle. In this section, we will obtain the trigonometric ratios of complementary angles in terms of trigonometric ratios of the given angle. So first of all, what is complementary angle? Two angles are said to be complementary if their sum is 90. Two angles are said to be complementary if their sum is 90 degree. Now let us consider the two complementary angles as theta, and obviously the another angle would be 90 minus theta. So there is a theorem connecting the trigonometric ratios, that is, if theta is an acute angle, then sine 90 minus theta is equal to cos theta. Similarly, cos 90 minus theta is sin theta, and tan 90 minus theta is cot theta, and cot 90 minus theta is tan theta. Then sec 90 minus theta is cosec theta, and cosec 90 minus theta is sec theta. Let us prove it. Proof. For that, let us consider a right-angled triangle OMP, which is right-angled at M. Let angle O be theta. Let this angle be theta. So obviously when angle O is theta, angle P comes out as 90 minus theta. So first taking angle O, that is theta, as reference angle, we can say sine theta is equal to Pm by OP, cos theta is equal to OM by OP, then tan theta is equal to Pm by OM. Similarly, cosec theta is equal to OP by Pm, sec theta is equal to OP by OM, and cot theta is equal to OM by Pm. Let this be the first set of equations. Now let us consider angle P, that is 90 minus theta, as reference angle. We can 90 minus theta is equal to OM by OP, then cos 90 minus theta is Pm by OP, and tan 90 minus theta is OM by Pm. Similarly, cosec 90 minus theta is OP by OM, sec 90 minus theta is OP by Pm, and cot 90 minus theta is Pm by OM. Let this be the second set of equation. And on comparing this first set and this second set, we can see that some of the RHS in first and second are equal. Let us sort it out. That is, sine 90 minus theta is equal to OM by OP, and this OM by OP in this second set of equation is equal to cos theta in the first set of equation. Therefore, sine 90 minus theta is cos theta. This is one of the relations that we have mentioned above. And similarly, in the case of cos 90 minus theta, it is Pm by OP, which is equal to sine theta in the first equation. Then we have tan 90 minus theta, which is equal to OM by Pm. Tan 90 minus theta is equal to OM by Pm in the second set of equation, and in the first set, OM by Pm is the ratio of cot theta, is equal to cot theta. Similarly, cot 90 minus theta, the second set of equation is Pm by OM. Therefore, tan theta of the first equation is Pm by OM. This implies cot 90 minus theta is tan theta. This is the case with sec and cosec. That is, cosec 90 minus theta is equal to sec theta, and sec 90 minus theta is equal to cosec theta. So from the above equations obtained, we can summarize that sine 90 minus theta is equal to cos theta, or cos 90 minus theta is equal to sine theta. Tan 90 minus theta is equal to cot theta, or cot 90 minus theta is equal to tan theta. Then cosec 90 minus theta is equal to sec theta, or sec 90 minus theta is equal to cosec theta. This is the sum of the relation. Hence it is proved that it is